In these tutorials, we are going to talk about multiplication and division of two complex numbers in the polar form. Now let's start with the multiplication. Now these are the rules that you have to know when multiplying two numbers in the polar form. The first thing that you are going to do is you're going to multiply the moduli. So you multiply the moduli, and the next thing is you are going to add the arguments. Alright. So given these two complex numbers, z equals r1 cos theta plus I sin theta, and omega cos r2 cos alpha plus I sin alpha. If you want to multiply these two complex numbers, z times omega is going to give us r1 cos theta plus I sin theta multiplying r2 cos theta, cos alpha plus I sin alpha. Okay, so z times omega is going to be the first rule is to what? To multiply the moduli. So r1 times r2. So we are going to get r1 r2. Then we add the arguments or the angles. So we're going to have cos theta plus alpha plus I sin theta plus alpha. So at the end of the day, this is going to be our final answer. R1, R2 cos theta plus alpha plus I sin theta plus alpha. Okay, so this is how we multiply two complex numbers in the polar form. Now let's take real examples. Okay, so we have z equals 3 cos 30 plus I sin 30, and omega equals 4 multiplying cos 60 plus I sin 60. We are supposed to find z omega. Right? So z omega is basically z times omega. It's going to be 3 cos 30 plus I sin 30 multiplying 4 into bracket cos 60 plus I sin 60. Alright, so our z omega is going to be rules for multiplying two complex numbers in the polar form. We multiply the moduli. So 3 times 4 will give us 12. Then we add the argument. So I'm going to have cos 30 plus this argument. So 60 plus I sin 30 plus 60. So z omega is going to give us 12 to bracket cos 90 plus I sin 90. So z times omega in the polar form is going to give us this, but if you want to convert it to the rectangular form or the Cartesian form, you are going to have 12 out. Cos 90 is what? 0 plus sin 90 is what? 1. So I. So z omega is just going to be equal to 12i. So that's what you get when you find the product of z and omega. Alright, let's move on to the next example. Example 2. Given that u equals 6 multiplying cos pi over 4 plus I sine pi over 4 and v equals half into bracket cos 3 over 4 pi minus I sine 3 over 4 pi. So we have these two complex numbers and we are asked to find u times v. So we are finding u times v in the form a plus bi. So after finding our u times v, then we leave it in the what? In the Cartesian form. Alright. So our u v is going to be 6 cos pi over 4 plus I sine pi over 4 multiplying v, which is half into bracket cos 3 over 4 pi minus I sine 3 over 4 pi. Alright, now in multiplying two complex numbers in the polar form, you have to make sure that the operational sign here and here, they are the same. Here is negative and here is positive. So always it's advisable to change everything to positive, because the basic formula given was in what? In terms of positive operations. So the negative should be converted to what? To positive. Alright. So here we are having plus I sine theta, and here is minus I sine theta. Okay, so our u dot v is going to be 6 cos pi over 4 plus I sine pi over 4 times half into bracket. This is going to give us cos negative 3 over 4 pi plus sine negative 3 over 4 pi. You may ask that why is it that here we are having we were having 3 over 4 pi, but here I have changed it to negative 3 over 4 pi, and here we are having negative I sine 3 over 4 pi, but we are having positive I sine negative 3 over 4 pi. If you remember, cos is a positive angle. So if I have cos negative theta, is the same as cos theta, right? The same way, if I have cos theta, I can write it as what? Cos negative theta. So in this case, here I had cos positive 3 over 4 pi. So if I have cos 3 over 4 pi positive, I can rewrite it as what? Cos 3 over cos negative, sorry, cos negative 3 over 4 pi. So that's exactly what I did here. Cos 3 over 4 pi is the same as cos negative 3 over 4 pi. Then here too, we were having negative sine 3 over 4 pi. And we know that when we have sine negative theta is the same as negative sine theta. So when I am having negative sine theta, I can rewrite it as sine negative theta. So that's what's happened here. Mind you, the how do you call, the argument must be the same. So that's what we just did. All right. So knowing that, let's continue with the calculation. So now that we have all the signs to be positive, then we carry out our operation. So we have uv equals, we multiply the moduli. So 6 times half into bracket cos pi over 4. We multiply the moduli, then we add the arguments, right? So plus negative 3 over 4. So we're going to have minus 3 over 4 pi plus I sine pi over 4 minus 3 over 4 pi. So u dot v is going to give us 3 into bracket cos pi on 4 minus 3 over 4 pi is going to give us negative pi on 2. So negative pi on 2 plus I sine negative pi on. Alright, so we now have the answer in the what? Polar form, but we want the answer in the form a plus bi. So we just multiply this by this, this by this, and again this by this. So by so doing, 3 times cos negative pi over 2 is going to give us 0, because negative pi over 2, cos negative pi over 2 is 0. Since negative pi over 2 is in radians and converting it to degrees is 90, so cos 90 is 0. So we are going to have 0 plus, and negative sine negative pi over 2 will give us negative 1, right? So 3 times negative 1 times I, we are going to have 3i negative. It's our final answer. So in the form a plus bi, we are going to have just negative 3i. So it means the complex number do not have a real part. Alright, it is purely imaginary since we do not have a real part. So that is how we multiply two complex numbers in the polar form. Let's take our last example, then move on to how we divide two complex numbers in the polar form. Alright. Our last example, if a equals 5 multiplying cos 30 plus I sine 30, and b equals 3 multiplying cos 50 plus I sine 50. We are supposed to find a times b. So a times b is going to be 5 cos 30 plus I sine 30 times 3 cos 50 plus I sine 50. AB is going to give us rule for multiplying complex numbers in the polar form. We multiply the moduli, so 5 times 3, then we add the what? The argument. So cos 30 plus 50 plus I sine 30 plus 50. AB is going to give us 5 3 is 15. Cos 30 plus 50 is what? 80 plus I sine 80. So it's this simple. Alright, now let's move on to how we divide two complex numbers in a polar form. So division. So the rules are, the first thing that you're going to do is you divide the moduli. So in multiplication, we multiply the moduli, but in division, we divide the moduli. Then you subtract the argument. So how we do the division is opposite to how we do the multiplication. In the multiplication, we multiply the moduli, but in the division, we divide. In the multiplication, we add the argument. But then, what we have here, in the multiplication, we divide. In the multiplication, we add the argument, but in the division, we subtract the argument. So given these two complex numbers, z1 equals r1 cos theta plus I sine theta, and z2 equals r2 cos alpha plus I sine alpha. We are supposed to find z1 divided by z2. We're going to have z1 over z2 as our z1 is r1 over what? Cos theta plus I sine theta all over z2 as r2 cos r2 cos alpha plus I sine alpha. So what are we going to do? We divide the moduli, so r1 over r2, then we subtract the argument cos theta minus alpha plus I sine theta minus alpha. So when you do this, you are done. So this is how we divide complex numbers in the polar form. It's pretty much simple. Alright, let's take an example. Let's use the previous example that we used. So let's say we have z1 to be 3 multiplying cos 30 plus I sine 30, and z2 equals 4 cos 60 plus I sine 60. So we are supposed to find z1 over z2. So z1 over z2 is going to give us, what is our z1? 3 cos theta plus I sine theta all over 4 into bracket cos 60. Here I said theta is 30 plus I sine 60. So our z1 over z2, then we go by the rules. We divide the moduli, then we subtract the what? The argument. Minus 60 plus I sine 30 minus 60. So you're going to have 3 over 4 multiplying cos 30 minus 60 is what? Negative 30 plus I sine negative 30. But we all know that cos negative 30 is cos 30 and sine negative 30 is negative sine 30. So we can have our final answers. Let me write it here. Just coming. Let me write it here. Can have our final answer as 3 over 4 multiplying cos 30 minus I sine 30. That's what you are going to have. Let's take another example. U equals 6 cos pi over 4 plus I sine pi over 4, and V equals half cos 3 over 4 pi plus I sine 3 over 4. Let's find U over V. So our U over V is going to give us 6 multiplying cos pi over 4 plus I sine pi over 4 all over half multiplying cos 3 over 4 pi plus I sine 3 over 4. So we use the rules, we divide the moduli. So we have 6 divided by half, multiplying, and we subtract the arguments. Cos pi over 4 minus 3 over 4 pi plus I sine pi over 4 minus 3 over. So U over V is going to be 6 divided by half is more or less like 6 times 2. So 12 multiplying and pi over 4 pi over 4 minus 3 over 4 pi. Coming. Pi over 4 minus 3 over 4 pi is going to give us negative half pi. So we are going to have cos negative half pi plus I sine negative 1 over 2 pi. Like I did for the first one, if you have negative, cos of negative value is positive, because what is a positive angle or is a positive regression. Let me continue here. So since cos negative theta is equal to cos theta, you can say that here we are going to have 12 multiplying cos positive pi over 2 minus I sine positive pi over 2 as our final answer. Alright, so this is how we divide two complex numbers in the polar form. Alright, thank you for the watching video. Stay tuned for the next episode of complex numbers. Have a nice day.